Physics begins before mathematics. It begins in the human stance before the real, a mix of wonder, patience, and the hunch that the world is not chaos but patterned. We watch the sky return to itself, feel the stone fall, see the flame rise, and suspect that repetition is a clue. What follows in this essay is not a march of facts, but a recovery of posture. Not certainty, but attentiveness. Not slogans, but questions. We move from myth, stories that made the world livable, toward natural philosophy, where explanation shifts from divine moods to the order of nature itself. This is also a global story. Greece is one chapter, not the book. India, China, Mesopotamia, Egypt, the Americas, each cultivated ways of reading the heavens and the earth. Different methods, different metaphors, converging on the same intuition. Patterns can be known. Language matters too. Some traditions think in lines, before and after, cause and effect. Others think in fields, relation, balance, cycle. The paths diverge, yet the mountain is the same. Distinct grammars of thought, similar destinations. The aim here is modest and radical at once, to stand again at the beginning, to ask better questions, and to see that physics is not merely about matter and motion, but about how we attend to reality. With that posture in place, we can now watch myth thin into method. From myth to philosophy. The earliest answers were given in the form of myth. The cosmos was explained through gods and spirits, their dramas woven into the rhythms of nature. Thunder was the anger of Zeus. The Nile's flood was the breath of a god. These stories were not false in the way we sometimes imagine. They were frameworks for meaning, ways of making the world intelligible in an age before measurement. Yet myths, while powerful, left questions unresolved. Why did some events repeat predictably while others appeared chaotic? Why did the stars move in patterns too regular to be explained as the moods of deities? The first philosophers looked at this tension and asked whether the world itself, without appeal to divine whims, could carry its own explanations. Thales of Miletus claimed that water was the fundamental substance, the root from which all things came. His student Anaximander disagreed and posited the apeiron, the boundless, as the true source. Anaximenes, in turn, believed that air was the essence of reality. These may sound naive today, but they mark a profound turning point. Nature could be thought of in terms of principles rather than stories. Philosophy became a new language for wonder. Knowledge across civilizations. This shift was not confined to Greece. In India, Vedic and later Upanishadic thinkers wrestled with the relationship between the seen and unseen, describing cosmic order, Rita, as the ground of natural and moral law. The very rhythms of ritual, astronomy, and philosophy were linked to this conviction that the universe was not chaotic but upheld by a hidden order. In the Nyaya and Vaisheshika schools, we even find the seeds of atomism, the claim that matter could be broken down into indivisible units, a startling parallel to later developments in Western thought. In China, early Taoist and Confucian traditions framed harmony, balance, and cycles as intrinsic features of the world. The Tao, though elusive, was seen as the underlying pattern of both heaven and earth. The Yi Jing, Book of Changes, offered a symbolic language for transformation and flow, while Confucian scholars stressed the moral and cosmic resonance of human conduct with natural rhythms. Here, nature was not merely a backdrop to human life, but the very fabric in which humanity was interwoven. Babylonian astronomers, working centuries before the Greek philosophers, kept meticulous records of the skies. They tracked eclipses, solstices, and planetary paths with extraordinary accuracy, not out of idle curiosity, but to align civic life, agriculture, and religion with celestial order. Their clay tablets, filled with calculations, reveal a proto-scientific spirit, systematic observation, pattern recognition, and prediction. Egyptian engineers, too, displayed a profound empirical sensibility. The pyramids and temples, precisely aligned with the cardinal points in certain stars, embody not only architectural genius but a belief in the intimate bond between heaven and earth. The flooding of the Nile was anticipated, measured, and integrated into a calendar that gave structure to the year. The Mayan and Aztec civilizations across the ocean also cultivated intricate astronomical systems. The Mayan calendar, blending ritual cycles with solar and lunar observations, is a testament to how deeply the heavens were studied as a source of both spiritual and practical guidance. The Inca, though less textually oriented, embedded astronomical alignments into their architecture and agricultural terraces, reading the sky as a companion to survival. Each culture brought its own blend of myth, practice, and proto-science, but all shared the same root impulse. The world has patterns, and if we attend closely, we can discern them. These patterns were often clothed in symbolic or sacred language, but beneath the poetry lay a proto-empirical conviction. Nature is not random. Seen together, these traditions remind us that natural philosophy is not the possession of one culture but the flowering of a shared human desire to understand. Wonder, after all, is universal. And this universality teaches us something important. The story of physics is not the story of Greece alone, nor of Europe alone. It is the story of humanity reaching again and again toward coherence, toward the hope that reality, however vast, can be known. Language, culture, and the shape of thought. Ideas do not grow in a vacuum. They are carried by the vessels of language and nourished within cultural soil. The ways in which societies describe the world, whether in verbs or in nouns, in cycles or in lines, in stories of origin or in laws of causality, shape the horizons of their natural philosophy. In cultures where language emphasized temporality and sequence, such as the Indo-European family, questions often unfolded in linear form. What comes first? What follows? What causes what? The Greek word cosmos itself implied order, arrangement, a sequence of parts in relation. This lent itself to thinking about laws, about beginnings and ends, about chains of reasoning that moved step by step toward explanation. It is no accident that in this soil the idea of first principles and causal mechanisms took root. By contrast, in cultures whose languages emphasized non-temporal or cyclical structures, patterns of thought leaned toward harmony, correspondence, and balance. In classical Chinese, for instance, the very grammar often foregrounded relationships rather than sequences. Change was described less as a line moving from point A to point B, and more as a transformation within a field of relations. Hence, Taoist and Confucian thought approached nature through the lens of balance, cycles, and resonance rather than linear causation. The goal was not to find a singular law that governed all, but to describe the dynamic interplay of opposites, the yin and the yang. Remarkably, these different linguistic and cultural frames led to similar insights. Greek atomism and Indian atomism, though separated by geography, converged on the intuition that the world could be reduced to fundamental building blocks. Chinese correlative cosmology and Babylonian astronomy, though working with very different symbolic languages, both discerned order in cycles and recurrence. Each culture approached the same mountain of reality from a different path, guided by the grammar of its language and the metaphors of its culture. This diversity of approach reminds us that physics is not a single straight line of progress, but a tapestry of perspectives. The laws of nature are not written in Greek or Sanskrit or Chinese. They are written in the universe itself. Yet the way we ask about them and the paths we take toward discovery are deeply influenced by the words and worlds we inherit. The birth of the questioning mind. What truly distinguished natural philosophy was not a single answer but a new posture. The willingness to question received wisdom. Instead of accepting tradition as final, thinkers began to test ideas against experience and reason. The cosmos became less a stage for divine drama and more a puzzle that human beings could attempt to solve. This questioning spirit gave rise to debate. If Thales said everything is water, Anaximander countered. If Pythagoras found harmony in number, Heraclitus emphasized flux and change. These arguments may seem obscure, but they forged something essential: the belief that truth can be approached by comparing ideas, testing them, refining them. We sometimes forget how radical this was. To move from the gods made it so to perhaps the world itself carries laws was to shift the very axis of thought. It meant that the human mind was not only a receiver of stories, but a discoverer of structure, asking better questions. Natural philosophers did not yet have experiments in the modern sense, nor the mathematical apparatus that would later define physics, but they did have the courage to ask better questions. Why does the same stone fall again and again? Why do celestial bodies trace regular paths across the heavens? Why does change itself seem ordered rather than chaotic? These questions presuppose something revolutionary, that the universe is coherent. Without that assumption, inquiry would collapse into despair. If reality were random, no philosophy or mathematics could uncover its secrets. But if reality carries order, then reason is not a futile exercise, but a doorway into truth. This act of questioning laid the groundwork for the scientific method. Though centuries away, the spirit was already present. Attend carefully to nature, look for patterns, and let reason guide the way. Philosophy as foundation nano. It is tempting to see physics as divorced from philosophy, as though science outgrew its metaphysical parent. Yet the foundations remain philosophical. To measure is already to assume that measurement is meaningful. To seek laws of nature is to believe there is such a thing as lawfulness. Even today, debates about quantum mechanics or cosmology return us to the same philosophical ground. What is real? What is knowable? What is meaningful? Consider the conservation of energy. Before it was a formula, it was a philosophical conviction. Something must persist through change. Or think of the principle of causality, the belief that events do not arise from nothing but have reasons. These ideas rest on metaphysical commitments as much as empirical observation. Physics leans on philosophy more than it admits. In this sense, physics is not merely about matter and motion, it is about our relationship to reality. The very possibility of physics depends on philosophy's ancient wager that beneath the visible lies a hidden order and that we can discover it. A posture before the real belly. What we inherit from these beginnings is not only a body of knowledge but a way of seeing. To practice physics, or even to understand it as a curious reader, is to stand before reality with humility and attentiveness. We do not command the world to yield its secrets. We accompany it, asking, noticing, refining. Let this first step remind us, physics begins not with numbers but with awe. It begins with the human impulse to ask. To study physics is to cultivate not just skill, but a posture of reverence, curiosity, and patience. Try this. Step outside tonight. Look at the stars, or the quiet fall of rain, or the flame of a candle. Instead of rushing to explain, linger with the question, why is it this way and not otherwise? That question, humble and open, is where physics truly begins.